It has been known for a long time that at the center of most galaxies lies a supermassive black hole. At the center of our own galaxy, the black hole Sagittarius A** resides, which is relatively tiny, with a mass of around 4 million solar masses. However, the black hole that has now been discovered is a true giant, with a mass of 30 billion times that of our Sun. This makes it one of the largest black holes ever discovered. What's even more fascinating is that this enormous black hole was literally ejected from its home galaxy. Yes, you heard that correctly. Galaxies can actually shoot out these gigantic monster black holes through space, which might make you feel a little uneasy. This almost unbelievable discovery was made by a research team at Durham University in the UK. James Nightingale, who led the research, explained in an interview that this black hole is at the upper limit of how big we think black holes can theoretically get. In fact, researchers are no longer using the term supermassive to describe it but rather calling it ultramassive. To put things into perspective, our Sun has a mass of approximately 1,989 octillion kilograms, that's 1,989 followed by 27 zeros. In contrast, the newly discovered black hole has a mass of approximately 5,967 followed by 40 zeros. You're probably wondering where this black hole was discovered and whether it might fly past us. Fortunately, it was discovered in a galaxy cluster named AEL 121, which is about 2.7 billion light-years away from Earth. Despite its enormous size, it took a special technique to spot it at all. Black holes are famously invisible, only becoming detectable when they are consuming nearby matter. But this particular black hole seems to be inactive at the moment, with no matter near it to light up. Nightingale and his team managed to discover it using a method called gravitational lensing. The immense gravity of the black hole bends spacetime in such a way that it creates a magnifying glass-like effect, revealing not just the black hole but also providing valuable data about these mysterious cosmic giants. Perhaps you're someone who thinks a black hole is just a black, voracious, and invisible object, but that's not entirely true. The world of black holes is far more colorful and varied than you might think. These objects are, without a doubt, among the most fascinating structures in the universe. In purely physical terms, a black hole is an area where density is so high that neither matter nor light can escape the gravitational pull. Black holes are not technically black, but rather invisible. Scientists use this name because, to our eyes, a black hole appears as if it were black essentially because light cannot escape from it. The mass of a black hole is so immense that it bends space and time to such a degree that it creates a dent, pulling everything toward it. Once matter crosses the event horizon, it cannot escape. There are 4 different types of black holes: supermassive black holes, with masses ranging from 10,000 to several billion solar masses, medium mass black holes, around 1,000 solar masses, stellar black holes, about 10 solar masses, and primordial black holes, which are very small and hypothetical, with a mass comparable to Earth's moon. Primordial black holes may have formed in the earliest moments of the universe, shortly after the Big Bang, from variations in density. For physicists, black holes are a scientific treasure trove. Intriguingly, their existence was predicted long before they were discovered. Einstein referred to them as completely collapsed objects of great mass, or as points of no return. Later, terms like dark stars and black stars were used to describe them, until the physicist John Archibald Wheeler coined the term black hole in 1967 during a presentation at an international astronomer conference. Before their final discovery, black holes were just theoretical objects, large collapsed bodies that could bend space, stretch time to infinity, and break the conventional laws of physics within them. What happens inside a black hole is so bizarre that it transcends our imagination. Black holes are the epitome of the superlative, the almost incomprehensible. Inside them, the density is concentrated at a single point, known as the singularity, where all known physical forces increase to infinity. The process of decomposition of matter begins in the vicinity of the black hole, and once matter gets too close, it is stretched out like spaghetti. We don't fully understand what happens to matter once it crosses the event horizon, but one thing is certain: it can never escape. Presumably, only pure information remains. Despite our limited knowledge of black holes, there are still theories suggesting that their enormous mass is somehow stored within them after consuming matter. Black holes grow heavier with each meal, which raises fascinating questions about how they increase in size and what exactly happens to the matter they consume. You may be surprised to learn that Einstein himself did not believe in the existence of black holes, even though he had predicted and calculated them correctly. It wasn't until the late 1960s that more and more astronomical evidence pointed to their true existence. In 1964, researchers using a brand new radio telescope discovered a strong source of radiation in the constellation Swan. Further investigation led them to suspect that this object might be a black hole. This discovery was later confirmed in the 1970s by the Uru satellite mission, and the object became known as Cygnus X1. It was part of a binary system and had a massive blue supergiant companion star. Astronomers were able to observe the orbit of the companion star around an invisible mass, which confirmed the presence of a black hole. Despite these breakthroughs, it wasn't until more recently that we were able to directly photograph a black hole. The first ever image was captured in 2019, showing an orange-yellow ring around a black core in the center of the giant galaxy M87. This black hole had a mass of 6.5 billion solar masses when the image was taken, and its gravitational force acts as an engine for its galaxy. The immense gravity at the center causes the movement of stars and the spiral arms of galaxies, including our own Milky Way. When black holes consume matter, enormous amounts of force are released, sometimes producing massive radiating jets that extend far beyond the edge of a galaxy. Recently, the James Webb Space Telescope discovered 6 objects that may represent some of the first black holes in the universe. If these objects are indeed black holes, they would have formed just 500 million years after the Big Bang, making them prime examples of the supermassive to ultramassive category. But this raises even more questions. How could black holes grow so quickly, and how were they created in the first place? Researchers agree that medium and small black holes likely formed from the collapse of stars. However, the very first black holes may have formed from collapsing dust disks that never formed stars. The role of primordial black holes, seen as relics from the Big Bang, is still unclear, but if many of these smaller black holes were to merge, they could form even more massive black holes. Although we know quite a bit about black holes, there's still so much we don't understand, particularly about what goes on inside them. Since their discovery, there have been wild theories that black holes might be portals to other dimensions or alternate universes. Some suggest they could be white holes, or even massive stars from parallel universes. The only certainty is that the enormous mass of a black hole is concentrated at an infinitely small point, much like the one from which our entire universe is thought to have emerged during the Big Bang. This has led to other, even more speculative theories, including the idea that we might be living inside a black hole and that our universe could have been created from one. The renowned British astrophysicist Sir Roger Penrose even proposed that black holes could have existed before the birth of our universe in his cyclic universe theory. According to Penrose, black holes could be structures that transcend time and universes. One of the most intriguing questions about black holes is how we could ever retrieve information from inside one. Unlike stars or planets, black holes don't have a surface that we can study. They're more like drains in a sink that keep getting bigger as more matter is pulled in. We can only observe what's happening at the event horizon, the boundary around the black hole, but we can never peer inside it. Everything that gets too close to a black hole is broken down into its components, and whatever lies beyond the event horizon remains hidden. However, there may still be a glimmer of hope. Theoretical physicist Stephen Hawking discovered that, contrary to previous assumptions, black holes can emit something, a tiny stream of quantum particles that we now know as Hawking radiation. These particles are thought to be linked to the quantum state inside the black hole, meaning that even if they travel billions of light-years through space, a connection remains. If we could eventually develop a way to extract this information from the quantum particles, we might one day learn what's truly going on inside black holes. With the rise of quantum computing, supercomputers that could outpace traditional ones by orders of magnitude, scientists hope this new technology will help us find answers about the universe, possibly even shedding light on the mysteries of black holes. Stay tuned for more breakthroughs in this incredible field of study.